Assalamu alaikum, students. Thanks to Almighty, we are resuming our lectures after a month. Today we will start chapter number 24, which is about electrical potential, energy and potential. In our previous lectures, we studied about electric charge, electric field, force of attraction and repulsion, Coulomb's law and Gauss's law, and various symmetry problems were solved for electric field by applying these laws. This chapter also add more information in your existing knowledge. We will focus about energy associated with electrical interactions. You are familiar with electrical energy as our daily life is hugely dependent on electrical appliances, which are, for example, light bulb, refrigerator, microwave, air conditioner, TV, radio, and many others. So in mechanics, you already studied about work and energy. Now we will combine these concepts with charges, electric force and field. It will help us to solve the problems in the field of electricity. So let me briefly give you an overview of energy and work. So when a force F acts on a particle or a body of mass m, and that body moves under the influence of the force from point A to point B. The work done by the force is equal to okay. Now, when a charged particle moves in an electric field, the field exerts a force on a charged particle. Okay, let me draw an electric field. And a charge is moving under the influence of this field, which exert an electrostatic force F on it, and this charge moves from A to B. The work done would be given by as the particle is moving from A to B. Other important point is if the force is conservative. When the force is conservative, the work done by the conservative force is expressed in terms of potential energy. Let's suppose a particle is at point A at a height h from point B. When the particle moves from a point A where the potential energy is UA to a point where its potential energy is UB, the change in potential energy would be equal to V minus UA, and the work done by the force is negative of the change in potential energy. This is work done by a conservative force. Now remember, work is positive, it means UA greater than UB. It makes your delta U negative and potential energy decreases. Okay, this happens when a baseball falls from a high point A to a lower point B. Okay, if this is a baseball and it falls from a high point A to a lower point B under the influence of Earth's gravity, the force of gravity does positive work and the gravitational potential energy decreases. Now, what happens when a tossed ball is moving upward? Gravitational force does negative work and potential energy increases. Now, let's talk about conservation of energy. We knew total mechanical energy is equal to kinetic energy plus potential energy of a system. It holds for conservative forces like gravity or electrostatic forces. We can also write it as initial mechanical energy is equal to final mechanical energy or kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final, or change in delta Q is equal to minus delta U. So now we just recall our basic concepts. The next video is about electrical potential energy in a uniform field. Thank you.